So there's been a demonstration that's been on my to-do list for some time, and that's the chemiluminescence of Singlet oxygen. And I've always been kind of put off from doing it because of not having a chlorine cylinder handy, seeing that the actual sort of wash bottles that are often used in the traditional way of showing this demonstration, a little bit fancy maybe. I certainly didn't have it immediately to hand in such a way that I could quickly and easily show it to some students within school. And then I got thinking about whether or not I could actually generate some chlorine gas in situ, sort of microscale, and Bob Worley, of course, the king of microscale, very kindly pointed me in the direction of Bruce Matson's microscale gas chemistry, where my mind was blown as I realized that actually getting myself some chlorine that I can use and show in front of a class was as simple as this. What I've just done there is, in a matter of seconds, generated about 60 ml of chlorine gas that I can now just go and plug straight into a demonstration. No fuss. Let's find out how. Okay, so we're going to be using an adapted version of a technique that was published by Bruce Matson in his freely available microscale gas chemistry book. So I'm going to actually leave the link for that. It's going to be in the article. Of course, the article is always on the Education and Chemistry website, and hopefully the RSC will be kind enough to add a little link down in the description as well. When you have a look at this book, your ideas are going to be going crazy. There's so much good chemistry that you can be doing here with such simple equipment. A lot of people get put off by microscale chemistry because they think that they have to get like really special fancy stuff. I mean, you can get like these syringe cap heads, but just to try and illustrate how simple this is, I'm going to be working with some wall tack today to minimize as much as possible any sort of fancy special equipment. What do I have? I've got just a regular 60 ml disposable plastic syringe, and I just want to make sure that that's nice and freely moving. I've actually given this one a little bit of vegetable oil around the outside of the plunger just to make sure that that's actually moving nice and freely once it gets going, so that any gas that's generated doesn't require too much pressure to get that plunger moving. What else have I got? The stand here, obviously a conical flask, optional, but kind of handy, especially when I'm talking to video. What is required is like a vial cap, essentially something that's going to sit inside your syringe, and that's going to contain one of your chemicals. And you can see how this actually fits nicely within the syringe here. And then actually I'm going to sort of add the acid into the vial cap, and the bleach for this reaction is going to be drawn into the syringe from the bottom. And so you need a vial cap that's actually going to be able to still contain 1 ml of your acid and yet float. Okay, so something like this is just like, again, vial caps that I just found over in biology. Didn't need anything special for this to get going. Likewise, you need some kind of a well to draw up some liquid from. So I've got a dropping tile. You could also use a weighing boat. It doesn't really matter. The key thing is that you want to be able to get the end of your syringe into the liquid and draw up as much liquid as possible and as little air as possible when you do that. And for our reaction today, generating our chlorine, there's more than one technique that you can use for this. Again, sort of links available as ever in the EIC article, and hopefully there'll be some links down below. Here we're going to be using some 5 molar HCl and some fresh sodium hypochlorite bleach. Really important that you use some decent, fresh stuff. Obviously this won't work with peroxide-based bleaches either, so go out and get a fresh bottle if you want this to work. In the article I mentioned 6 molar HCl because that's what Bruce Matson uses, but 5 molar actually is perhaps more likely to be found around the department, and I find that works pretty well as well. So I'm just trying to show as much as possible what can be done with what was just sort of able to be gathered from around the department without people getting sort of freaked out that microscale chemistry needs some special kit or something like that. Okay, so what I'm going to do is draw in a ml of acid into my vial cap head, and then I'm going to actually pull into the base of the syringe my bleach, and I'm going to need 3 ml of bleach and 1 ml of acid. You want to get as close as possible to that 3 ml of bleach, because of course if you sort of go too far either side, you'll end up generating less chlorine. Now, Bruce Mattson, incidentally, always has this technique about sort of filling up the syringe with water, and then with your thumb underneath or something like that, and then floating in the reactants on the top, because normally it's a powder, and then sort of letting your finger off and allowing the liquid to sort of run down. In our case, we don't need it, because actually we can load the acid straight into the vial cap using a dropping pipette. Thanks to Peter Boris from Kleeps for actually pointing that out to me. Sometimes you can't see the wood for the trees, so that's what we're going to do today. There we go. So at this point, I just want to put a little cap on the end of my syringe. So with the acid and the bleach in place and the cap on, the last thing you need to do, of course, in the fume cupboard is to flip over the syringe, give it a little bit of a shake, and potentially assist the plunger in moving backwards. At this point, you'll find that the syringe will basically be full of chlorine gas, and there's going to be some unreacted liquid that you want to get rid of in there as well. Now, to do so, I've got a waste beaker with some 1 molar sodium hydroxide in it, but you've got to be careful, of course. There might be a little bit of positive pressure in here from the chlorine, so what I'm going to do is leaving the syringe facing upwards, pointing it away from my face. I'm actually going to draw back a little bit on the plunger just to reduce some of that pressure as I take the cap off and flip over, dropping out any of the excess liquids into the waste beaker with a minimal loss of chlorine as I'm doing so. So we've generated some chlorine in a syringe. What are we going to do with it? Let's see if we can observe the chemiluminescence of Singlet oxygen. Now, to do that, you can see here how I've got a clamp stand with a dummy tube of chlorine that I've sort of got set up here. On the end of that, there is 5 to 15 centimeters of silicone tubing. It doesn't really matter too much. The key thing is you've got that bend that you can generate to deliver a pasta pipette into the base of a medium-sized test tube. And in the medium-sized test tube, I have some 100-volt peroxide. And just before I get going with the demonstration, I'm going to add some 6 molar sodium hydroxide, 5 ml here, made by adding 1.2 grams of sodium hydroxide to the water. The reason I'm not going to add it immediately is that the alkaline peroxides can begin to decompose. So I really want to just sort of add that in when I'm ready to go. So I'll connect up a genuine tube of chlorine gas here, add my sodium hydroxide, dim the lights, and we can see the chemiluminescence of Singlet oxygen. So I've lowered my syringe into the solution now. All I need to do is start squirting. The key thing is to try and sort of pump in the chlorine in little bursts, because you'll find that the bubbles that are generated in the peroxide can cause it to get a little bit cloudy and obscure the best of the red glow. Let's have a look and see how we get on. So there you have it. Singlet oxygen chemiluminescence demonstrated in a quick and easy reaction there with the help of Bruce Mattson's fantastic microscale gas chemistry, generating some chlorine in situ. And you can believe it won't be the last time we'll be exploring some of Bruce Mattson's beautiful syringe, in situ gas generation techniques on this column in the future. But for now, give this one a go.